Solution to a 3-mark question that appeared as part of the sample paper given by CBSE in 2019 for class 10 math. It's a very straightforward question from real numbers. We need to compute the HCF of two numbers, 726 and 275. We have multiple ways of computing the HCF. This question has specified the method. It wants us to compute the HCF using Euclid's division algorithm. In this slide, what we'll do is we'll list down the steps required to compute the HCF using Euclid's division algorithm. Step 1, we will take this larger of these two numbers, 726, as the dividend and we'll call it as n. And the smaller of these two numbers, 275, and call it as the divisor d. And write these two numbers to fit into the Euclid's division algorithm. That is essentially, we'll write this number, larger number 726 is equal to some q times the divisor 275 plus the remainder r. Q is the quotient of this division, which is a positive integer. R is a remainder of this division, and the remainder could take values which range from 0. It could very well be a 0, and it can go all the way up to d minus 1. The remainder can never be equal to the divisor, can never be a value which is greater than the divisor. So the first step, we'll write 726 is equal to some q times 275 plus a remainder if 1 exists. If the remainder of this step is not equal to 0, we will repeat step 1, making two adjustments. We will make d of step 1 as n for step 2, and we'll make r of step 1 as d for step 2. Essentially what we are doing is we are picking the divisor of step 1 and making as a dividend for step 2. We are taking the remainder of step 1 and making it as a divisor for step 2. And we'll continue with this process. We'll keep repeating it till that step in which we get the remainder to be equal to 0. The step in which you'll get the remainder to be 0, the divisor of that step is the HCF. Let's run through this process with this example so it gets very clear to us. We'll start. In this case, we have 726 as greater than 275. So 726 becomes our n and 275 is our divisor. Let's apply it. I'm writing step 1 here. In step 1, 726 equals 275. Let's see whether it will divide it. 275 into 3 is 825. 275 into 2 is 550. So it does not divide 726. It goes twice in it. So let's write it as 2 times 275. That's 550. Plus we'll have 176. The remainder of this step is not equal to 0. Let's move on to step 2. In step 2, the adjustments we are going to make is we're going to apply this lemma on 275 as a dividend and 175 as a divisor. So we'll write 275 equals some times q times 176. 176 goes once in 275. So 1 times 176, and the remainder in this case is equal to a 99. The remainder in this step is also not equal to 0. So we'll repeatedly keep doing this thing. Step 3, what is going to be the number for us or the dividend? The dividend is equal to 176, which is the divisor of the previous step. What is going to be the divisor? The remainder of the previous step, which is 99. So we're going to write 176 as q times 99. How many times 99 will go in 176? Only once. So 1 times 99. And then we still have a remainder, which is equal to 77. Remainder of this step is also not equal to 0. So let's move on to step 4. In this step, 99 is going to be the number for us. The divisor is going to be equal to 77. 77 goes once in 99. That's quite evident. Do we have a remainder? Yes, we have a remainder which is equal to 22, which is not equal to 0. Continue with the process. In step 5, the number is going to be 77 for us. The divisor is going to be the remainder of the previous step, which is 22. How many times will 22 go in it? Thrice. So 3 times 22 is what we have. We still have a remainder which is non-zero. The remainder of this step is also not 0. So let's go on to step number 6. In this step, we'll take 22 as a number or as a dividend, and the remainder of the previous step, 11, is going to be the divisor. So 22 equals 2 times 11, and the remainder of this step equals 0. This step, the remainder is equal to 0. So divisor of this step, 11, happens to be the HCF of these two numbers, 726 and 275. Quickly run through this entire thing in a printed form so we can recap it and wind this question up. We're going to apply the Euclid's division algorithm. We'll take n to be the larger number, d to be the smaller number. Q is how many times this d goes in n. And if there is a remainder, we'll keep that remainder. If the remainder of the step is non-zero, which is what it is, we're going to repeat this process with n to be equal to 275. We'll apply the Euclid's lemma on 275 with 176 as the divisor. So 275 equals 1 times 176 plus a 99. The remainder of this step is also not equal to 0. So in step 3, we'll take n as 176. So we'll apply the Euclid's lemma on 176 with 99 as a divisor. 99 does not divide it perfectly. 99 goes ones in it. So 176 equals 99 times 1 plus 77. The remainder of this step is also not equal to 0. For step number 4, this number is going to become n and 77 is going to become our divisor. So we'll apply the lemma on 99 with 77 as a divisor. 77 goes once in it, leaving a remainder of 22. So repeat the step because the remainder is not 0. However many steps it takes, we have to go on. So in this case, we're going to write 77. We're going to apply the lemma on 77 with 22 as a divisor. So 77 equals thrice 22 plus 11. The remainder still is not equal to 0. So we're going to apply the lemma on 22 with 11 as the divisor. In this step, we got a remainder which is equal to 0. The step in which you get the remainder as 0, the divisor of that step, which is 11, is the HCF of these numbers. So HCF of 726 and 275 is 11. Before you leave, do two things. Sign up at online.maxtute.com for CBSE online maths coaching. Takes all of 3 steps in less than 5 minutes to get started. And subscribe to the channel youtube.com/maxtute and spread the word among your friends and classmates.